So in this video I'm going to talk about two things, dimensional analysis and the metric system. You can think of dimensional analysis as a way to solve unit conversion problems. It's a way to do that. And we'll be using it a lot when we talk about the metric system, which is made up of different prefixes added to the same unit. So looking at the relationship between 1 kilogram and 1 picogram is all about we'll be using dimensional analysis, and I'll talk about more about that in a second. But for now, let's talk about dimensional analysis. It's not the only way to solve these problems. If you've got your own individual way, that's great. I'm going to show you this way, but I think it's a good way to keep track of the units that you want to cancel and the units that you want to keep. So what I'm going to do is set out a table. And you can think of this as an equation. Instead of the vertical lines, you could have multiplication signs. And then this big horizontal line is like a division sign. So if that's helpful to think about that. So we'll multiply out the top row and then we'll divide out by whatever's on the bottom row. So the way to start with dimensional analysis, after you've drawn your table, or you can draw your table as you go, it doesn't matter. But you're going to take this number that you've been given and put it in the top left corner. And I wrote meters divided by seconds because when you work out speed, you take distance and divide it by time. So this would be 3 times 10 to the power of 8, and this would be 1 second. This number is actually the speed of light. That's how many meters, so 300 million meters in 1 second is the speed of light. Alright, so we're going to take meters and divide it by 1 second. So the way to deal with this table method is to look at the unit that you've got up top. And if you want to get rid of it, you're going to put it down below so you can cancel them. So you don't need to memorize this, but it's good if you can remember. But you'll be looking up a lot of metric conversions and different other unit conversions online because it's easily accessible. I just know that there's 1,600 meters in 1 mile, which is not exact, but it's rounded up just a little bit. I think it's 1601. So what I've got here is meters and meters. I'm going to deal with seconds separately after I've finished with the distance unit, just because it's easier that way. You could start with seconds and cancel them out, but it's just a preference thing. So you're going to take meters, and we can cancel these now. We're dividing by the same unit, so they're going to cancel each other out. So let's say, for example, you were solving an algebra problem, just to give this explanation a bit more depth. If you want to solve for x, you divide both sides by 2, so x would be equal to 2. Because you're dividing by the same thing, you can cancel things out. And so same applies here. Dividing by the same thing, we can cancel them. So we've got rid of meters and we're in miles, which is good. So now we want to get rid of seconds and get into hours. So I'm going to fill in what I know. I know that there's 60 seconds in 1 minute, and then 60 minutes in 1 hour. So I can cancel out seconds and seconds because I've got the same thing above and below. Same thing with minutes, they go away, cancel, cancel. So now what I'm going to do is take this number, multiply it by 1, then by 60, then by 60 again, and then take 1, divide that by 1, multiply by 1600, and 1 and 1. And obviously you're probably thinking I can just not do that one part because it's going to keep the same number the same. So let's do that really quick and see what we get. So I don't need this many vertical columns, and the units that I've ended up with are miles per hour. So that'll be 1, so 3 and 6. 6. So changing this many meters per second into this many miles per hour gives me this value. Not too many zeros. Always check your work, so you don't make mistakes. So that would be the result here. So the big recap of dimension analysis is that the number that you've been given goes in this top corner, and then just put the units underneath so you can cancel them. The conversions you don't need to memorize. Seconds in minutes, minutes in hours, you can probably remember, but that's the idea. Okay, so with the metric system, we'll use this method, dimensional analysis. But it's a little easier calculation, so hopefully that'll help. So maybe if you can see these exponents, it starts with kilo is 10 to the power 3, which is 1,000, milli, which is 10 to the minus 3, which is 1,000th, and then it goes down by 3 every time. Centimeter is kind of off on its own, it's 10 to the minus 2. And so it doesn't really fit that trend, but the others do, and that's another nice trend about the metric system, if you can remember that. So the big idea of the metric system is that you've got a base unit, say for example 1 meter, but if you put the word kilo in front of it, you've got 1,000 meters. And so then the idea is that this prefix tells you how many meters there are. So if you have 10 to the power of minus 3, that's the same as 1 over 1,000. So if you have 1 meter, that's going to equal 1,000 millimeters. So I've used scientific notation here mainly because you're all experts now, and hopefully this is actually manageable. And it saves you writing out all those zeros, which can be kind of a pain, and you can forget one. If you can remember the exponents here, I think that's going to make life a little easier. But the big idea of the metric system is you're going to take a unit and put a prefix in front of it, and that can mean many, many more of those units. Say, for example, meters, 1,000 meters. Or if you're measuring something a lot smaller, like millimeters. If you're dealing with cells, you'll use micrometers. And in 1 meter, there's actually 1,000,000 micrometers, and that's the symbol which we'll talk about in class. And you'll have that in your notes as well. But there's different symbols, so you don't have to write the full word, so it makes life a little easier. So if we went down to nano, which is roughly in the ballpark of an atom, say for example the diameter of an atom, that would be billion. So with 9 zeros, nanometers. So if it's starting to make a little more sense now as I've written out the zeros, a meter is 1,000 millimeters. A meter is also equal to 1,000,000 micrometers, and it's also equal to 1,000,000,000 nanometers. So there's definitely a trend of kind of adding more zeros as you go. So you're just changing the prefix. So this number of millimeters is equal to this number of micrometers, which in turn is equal to that many nanometers. Depending on what you're measuring, it can be more convenient to use these rather than millimeters. So you wouldn't use, like if you had a big long measuring stick that measured 1 mile, you wouldn't want to measure the width of your fingernail with it because the unit would be really, really small. So it makes it a little bit more cumbersome. Alright, so let's practice operations with the metric system. It's actually going to be utilising the dimensional analysis, which we talked about. And again, you won't need to memorise the conversions. These will be given to you. If you can remember them, though, in the scientific notation form, I think it's going to make life a little easier, which is nice. Alright, so let's do an example. Let's convert. Let's do 50. So we'll change 50 kilometres into centimetres, which, let's say that you are doing a calculation and the calculation requires a constant, and that constant deals with centimetres and other units. So if you have a measurement of 50 kilometres, it's got to be in centimetres, otherwise you can't use that constant. So this is it's an example of that. You probably wouldn't deal with kilometres and centimetres, but the principle is the same. So we're going to use this information on the side here, and we're going to use dimensional analysis. Give myself a few boxes. Follow that same guideline of taking this number and putting it in the first top left box. So then what I've got to look for is a conversion between kilometres and centimetres. Oh no, there isn't one. But what I do know is that 1 kilometre is equal to 10 to the power of 3 metres. I could write out 1,000, but this seems a little easier to me, so I'm going to try that. Just try writing the scientific notation. And then I know that in 1 metre, there's 100 centimetres. So I'm able to cancel out kilometres because I'm dividing by them. I'm able to cancel out metres, same idea. Now what I've got to do is multiply out the top row, divide by the bottom row. So anything where there's ones, you don't need to really do anything. So really all I've got here is 50, 2 zeros and 3 zeros. So that would be, oops. One, two, three, four, five. Oh, I was right first time. So 5 million centimetres is equal to 50 kilometres. Using dimensional analysis keeps it relatively straightforward, and if you can just keep track of the units as you go, like you're zigzagging along, and then multiply the top row, and then divide by the bottom row. You don't need to memorise this information, but if you, just for speed and convenience, if you do memorise it, that does follow a nice pattern of adding zeros as you go from 10 to the power minus 6 to 10 to the power minus 9, and so on. So that's dimensional analysis and the metric system. We could basically change this n in metres for anything, grams, litres, any unit, any metric system unit, excuse me. And we can use dimensional analysis to convert between different sets of units, depending on what we need. And that's it.